Hello everyone, my name is Nasi and I will present a part of my work regarding the association of relativistic electron enhancement with VLF and ULF waves and seed electrons. Local acceleration driven by Whistler mode coarse waves is fundamentally important for the acceleration of seed electrons to relativistic energies in the outer radiation belt. This mechanism strongly depends on substorm activity and on the source and seed electron populations injected by the substorms into the inner magnetosphere. We investigate solar wind and geomagnetic parameters, wave activity, and the source and seed electron phase space densities, looking for the occurrence of characteristic patterns by performing a superposed epoch analysis. Covering the RBSP era, we examine events that satisfy the criteria of quiet interplanetary and geomagnetic conditions during a 12-hour pre-disturbance time period, meaning no high-speed streams or coronal mass ejections, no southward interplanetary magnetic field, no magnetic storms, and no substorms, according to the work of Katsavrias et al. 2019. The event end time is defined by the return of four parameters to their pre-event levels. Because substorm activity does not always coincide with or depend on magnetic storm occurrence, we have not limited our study to storms, but have included also non-storm events that are able to cause enhancement or depletion of the relativistic electrons in the outer radiation belt. We perform a superposed epoch analysis with zero epoch time T0 corresponding to the start of substorm activity as indicated by declining AL index, as the seed electron population variability is directly affected by substorm injections expected to begin after T0. The aforementioned conditions yield a total of 28 single and isolated geomagnetic disturbance events, out of which 20 result in enhancement and 8 in depletion of the relativity electron PSD. The central line corresponds to the median and the others to the 25 and 75% quantiles. The enhancement and depletion events will be shown in the same plots for each parameter, with green corresponding to enhancement and orange to depletion events. Hereafter, when referring to a specific parameter, we will be talking about its median values. All calculations were performed following methods and using data provided on screen. Hereafter, we present our results. We can see that enhancement events are caused by disturbances exhibiting prolonged southward interplanetary magnetic field, highly increased and long-lasting solar wind velocity with values reaching over 500 km per second, together resulting in enhanced magnetic reconnection at the dayside magnetopause. Additionally, enhancement events are characterized by prolonged negative CMH and AL indices, meaning statistically stronger and more prolonged storm and substorm activity, and also a significantly compressed plasma pause, reaching regions under 4 Earth radii. Moving on to the wave activity, we can see that not only the coarse wave activity is more pronounced at larger L values, but it is also more persistent. At L between 3 and 4, the waves are almost negligible, and this is probably related to the plasma pause location. At L 4 to 5, the enhancement events exhibit more intense and prolonged coarse wave activity, something still happening at L 5 to 6. The PC5 waves appear more pronounced and prolonged for increasing L star values during enhancement events. Again, at L star 4 to 5, the enhancement events exhibit the biggest difference in wave activity, with the PC5 waves being more intense for a longer time. Finally, we calculate the electron phase space density as a function of the 3 adiabatic invariance. We investigate near equatorial mirroring source and seed electrons in 3 distinct sections of the inner magnetosphere. In enhancement events, the source electrons appear more inward but are comparable at L star 4 to 5. However, the seed electrons appear significantly more to L star 3 to 4 and 4 to 5 in enhancement events, but are almost insignificant in all other cases as they never reach values 1 order of magnitude larger than those of the pre-event phase. This suggests that the appearance alone of source electrons does not necessarily lead to the appearance of seed electrons, so there must be additional mechanisms responsible, such as either injections directly from the plasma sheet caused by substorm activity, or the diffusion of electrons located at larger L star, or even the energization of source electrons. In summary, the most important conclusion of this study is that the enhancement of seed electrons, along with prolonged and intense ULF and VLF wave activity, and also an earthward displaced plasma pause, are important conditions leading to substantial enhancement of relativistic electrons in the outer Van Allen radiation belt. Continuing this work, we further investigate the relative role of the two wave types on producing this energization. Thank you everyone for your attention.